I am recording now. Hi, Melanie. I think she's going to watch this too. So nobody say anything bad about her, okay?
Are we talking about Melanie
No,
now?
we're not. No, we're not. That can be later. Okay, so we are going to rewrite this first one. We're going to be using it a lot in our proofs. So we're going to rewrite this first one a lot. What is sine on the unit circle? Y, and this is x. Okay, so I'm going to rewrite this right here. We're going to rewrite this a whole bunch of times. I'm going to write x squared plus y squared equals 1. And just so you remember what we're talking about, I'm going to write cosine squared theta plus sine squared theta equals 1. Now sometimes we end up replacing cosine squared theta with something. If I solve for cosine squared theta right now, what would I get? What? So if I solved this equation right here for cosine squared theta, and I moved the other stuff out of the way, what would it be? 1 minus sine squared, right? Because I'd have to minus sine squared from both sides. You guys seeing it? What if I solved that equation for sine squared instead? This top one. What would it be? Yeah, same thing but cosine. Okay, now we're going to be, do you guys realize that this is all the same formula? Yeah. X squared plus y squared equals 1, cosine squared plus sine squared equals 1, cosine squared equals 1 minus sine squared equals 1 minus cosine squared. It's just we're going to be using this a lot. And so we're kind of putting it in a format that is easy to read. Okay? All right, now this one is going to be a little harder to understand, but we're still going to go through it. These are called the even odd identities, and we're putting them up here. I'm trying to put all of these rules on one sheet so that you have something to reference pretty easily while you're doing your proofs. All right, I just wrote sine of negative theta equals cosine of negative theta equals and tangent of negative theta equals. These are ones that we're actually going to figure out ourselves. There are some formulas in here that are not worth our time to prove. It's like, like occasionally, I think I try to do it, what I try to do as a teacher is I try to often show you why things are true instead of just saying that they're true. But I am going to be doing a few formulas this chapter where it'll just be just write it down, okay? Just write it down because you're not specializing in trigonometry. Even in a college class, you probably wouldn't have to prove some of these, but there are some that I can prove easily enough that I will. All right, the sine of negative theta. So let's pick a angle. Let's pick 60 degrees. Everybody look at 60 degrees. What is the sine of 60 degrees? Square root of 3 over 2. Is everybody comfortable with this, right? Square root of 3 over 2. That's the sine of 60 degrees. Yeah. What is the sine of negative 60 degrees? Where's negative 60 degrees? 300. And what is it? Negative the square root of 3 over 2. So see how it's the exact same thing? It's just one's negative, one's positive? Okay, so I'm going to write The sine of negative theta is negative sine of theta. What that means is that you take whatever the sine of theta would have been, and you just make it negative. So they're opposites of each other. One's positive, one's negative, or if the other one was negative, the other one would be positive. Okay, how about the cosine of 60 degrees? What's the cosine of 60 degrees? 1/2. And what's the cosine of negative 60 degrees down here?
1/2.
It's positive 1/2 still, isn't it? Why?
Well, because you're not going anywhere on the x-axis.
Right, the x is still positive on the right. So actually, on the back side, it's just a positive cosine of theta. Tangent. The tangent of 60 degrees, now we don't actually have to figure it out, but let's just look really quick, everybody look up, is what? Taking the y divided by the x, right? We don't actually have to do it right now, but if I take the y divided by the x, would it be positive or negative in this quadrant? Positive. All right, now let's go down here. If I take the y divided by x down here, would it be positive or negative? Negative. All right, now just to write it out all the way, we're also going to do cosecant, secant, and cotangent. But what is cosecant the opposite of, the inverse of? Sine. So we're just going to copy the exact same rule right next to it for cosecant. The cosecant of negative theta is equal to negative cosecant theta. Because I know that the y will change from positive to negative, going from the first to fourth quadrant. Same thing with cosine. The inverse of cosine is secant. Secant of negative theta equals negative secant theta. Positive, you're right. I don't like how many white marks I've got going on this. Is this dead? Oh, cool. Remember that day I was gone and Math 9 was graphing all those points, right? They were doing like a big picture thing where they were graphing points. And I left all of my whiteouts sitting on the shelf, okay? The plastic is completely gone off this. There's no plastic whatsoever left. 3 out of 4 of them were destroyed by the 9th graders. And I'm guessing I bet at least one of them was an accident. Maybe the other ones weren't. Okay. So the last one is cotangent of negative theta. Did anybody have the guts to already write this one out?
Yeah, no.
Good job.
Nope.
Negative cotangent, you're like, she might write something different. I'm not chancing it. And I will show you how we use these.